So welcome everybody. Thank you for attending our session with the title Killing Pets with CPET, the donkey and the PaaS operator. So it's a teaser, of course, because you can interpret it a lot of ways. I mean, there's two abbreviations like CPET, PaaS. What does it mean? Pets and killing pets. I mean, the donkey. What do we mean by it? It's a lot of interpretation that's possible. But before we start actually talk about the presentation and diving into the content, first let's introduce ourselves. So the first one is Benoit Schipper. He's not on stage because that's us two, but Benoit is seated over there. He's the one who enrolled us, who enlisted us, so that's why we're actually here. So thank you very much, Benoit. And the next one is Sebastian Mannem, and perhaps he can introduce himself.
I am Sebastian Mannem. I'm currently running a startup, and one of my first customers was the Dutch tax office. And I am so, I'm amazed to be part of this journey actually. So, yeah, great to be here. Thank you.
So my name is Jan van Hermon. I work for the Dutch Tax Administration. Actually, I'm a civil servant. So, and I work with the CPET. So we're now starting into the presentation already. So I can explain a bit about the abbreviations and the words that here, and also to explain what actually we want to express with our presentation, what we want to explain to you. So CPET is the Container Platform Enablement Team of the Belastingdienst. So that's the Dutch Tax Administration you see in the upper right half. So it's about enablement of development teams, give them velocity so that they can produce quickly their applications in various stages of their work. The Dutch Tax Administration is a very big organization, of course. So we've got a lot of teams. So if we're talking about enablement, we're talking about enablement at scale, and that is one of the challenges we're facing the last 3 years actually, but mostly the last year or so. And then the other word is PaaS. You can interpret it as well as various ways. It's an operator, and it's not the way most people know PaaS, because in this case it's a project as a service. That's what we named our operator. Sometimes we think that is a pity that we haven't chosen another word. So a PET is also a platform enablement team. So we've been also in contact with platform enablement teams of other administrations. We're not going to kill them. We're much more talking about the pets over there, of course, and people know like pets, cattle, that will be in our presentations as well. And the donkey, well, we'll get to the donkey later on in our presentation. So basically it's about enablement, and it's about enablement at scale. So that's the base thing we're going to talk about. And talking about agendas, first I'll give you some context of our organization, a bit of history so that you know what we've been through and why we made certain choices, the choices we made to, have our organization, our team, the Container Platform Enablement Team, to be at the place where we are right now. And also why we made this operator. We're going to talk about enablement at scale, so a bit of history. And eventually we talk about our operator, the project as a server operator, and we have also a small demo at the end. Sebastian will give it. So let's hope the demo gods are with us. That's the demo. If we talk about the what is the CPET doing? It's a long story, of course, but of course, just to focus on the blue parts is enabling DevOps teams. We're largely on mainframe and on-premise, not on OpenShift. So we're moving with a lot of applications to OpenShift. We're working on CloudNative. That's what we want to go to. But there's also a lot of lift and shift. There's a lot of applications that still have to be moved to OpenShift. So enabling at scale already, because there's a lot of things coming on. And the other part of perhaps our mission, which is interesting, that the teams are able to use a container platform and are able to use. So what we don't do, our vision is not that we give us your application, somewhere we will build it, somewhere we will deploy it, and we are in charge and you can forget about the rest. Now our vision is that the developers They know what they're doing. They are in charge of their own deployment repo. They know what a deployment is, and we work actually as GitOps. And we also strive to build applications, cloud-native applications, that can be managed by the platform, and that the platform that they can use the capabilities of the platform, and that they provide, and that we provide environments for build, deliver, and run. So it's not just I have it deployed, it's running, but I also have an environment to build, and I have also the possibilities to deploy my application. So that's our mission. And how do we do that? I go back just to go forward again. So what we do is onboarding teams. So what type of application do you have? How can we help you to make this application ready for OpenShift, for the cloud platform? We do consultancy, so there's a service desk. You can put in tickets, and we try to help you as soon as possible. Of course, there's meta modes that we follow, but in order to organize our work and not be bothered every day, all day, and trying to resolve the issues of people, there's this service desk. You also can call us, and then we go to your team, help you online, and just work together on the issues you are facing, of course. Look at your application architecture and stuff like that. The configuration of cluster and projects. If people want operators, we can provide them on the platform because we're air-gapped, so there's some stuff we need to do to get these operators available. And also we look into make documentation for these operators if you want to use them in the correct way. We provide products like images, the operators I was just telling you about. And we also, of course, if we got the time, and now we're in the moment in time where we have more time, do research on new operators, new images, innovation, looking at other clouds and stuff like that. So that's what we do. Of course, we're not doing it alone. There's a context. There's also, of course, infra, so networking, storage and stuff like that. And there's the container infra team. That's a team that actually delivers us the OpenShift clusters. So we don't maintain or we don't do upgrades from OpenShift 4.12 to 13. The container infra team is doing that stuff for us. So we, as a container platform enablement team of CloudNative, that's the old term, we just ask the SID, we want 2 more clusters, they deliver them, and then we put our stuff on top of it so that the teams have the capabilities to build and deploy the applications and run them. We've got a focus on cluster, so the platform, putting the software or operators on top. Middleware focus, that's the operator part, and the software focus is more the enablement of the teams helping to build cloud-native applications. And of course, on top of the business, they want actually business value, and the DevOps teams are delivering it. So we're somewhere in the middle, as you can see, and this is us stuff. Enablement and collaboration, that's the difference. Now the context, it's short history. We started off in 2019, I wasn't there yet. It's Jeroen Wolf, our lead architect, our architect of the team at the moment, who was interested in cloud. It's new for the Belastingdienst, for the custom, for the administration. And also with a vision that in the old situation, there was this web application server and you had to do with the version they were running. You couldn't do other stuff. You couldn't use other tools. You were like bound and tied to what the administration was delivering for you. So he was looking in cloud and with another co-worker, they started their journey and started experimenting with OpenShift. And also like responsibilities, is this something for the container infra team? Is this something for the teams? Is this something for the enablement team? And there were like 5 teams or so that were experimenting with them. In 2020, we started productizing the first like operators or stuff like Selenium Grid, put on Jenkins, and the teams grew. There were 10 teams by then. The same number of CPET members. So these are like the topics we are looking at. In 2021, I joined the team, and we put on Grafana, Tekton. Team stayed the same. In 2021, one of our team members who's here left, so we went from 3 to 2 members of the CPET. The number of teams grew, And then we had seal secrets put on. In December of the same year, we were at 20 teams, and we started to manage projects, UB-based images. And luckily, Benoit, Sebastian, and a few other members joined, because by December, I was practically on my own with the architect, and we were only managing tickets. There was no time for other stuff. So you see, things were growing very rapidly, because this is incremental, of course. ArgoCD we worked on half this year, and Postgres. The number of team members went up to 8 and then to 40. Now we're at 50, and luckily we got more team members. So actually now we can start doing stuff, and that's also when we put on this focus where I was talking about just now. So you could see we were like facing a lot of challenges, and Benoit told us a lot of times beginning of this year, we need guardrails, we need guardrails. We need structure on our clusters, because we started with the vision like, let them do their stuff, the developers, and they had self-provisional rights, and they could create their own namespaces. So there were no name and culture, there weren't like actually rules of naming namespaces and stuff like that. All namespaces had different configurations, so that was nice for them, the liberty, but for us hard to help those people, because every situation was different. Another stuff is like, we need to automate. This is what Sebastian said. And of course that's all true, because if you see the trends going up, we know we're going to grow to 100 teams. So how do you enable 100 teams if you got all these operators, all these tools, the images to maintain? It's hard to do. You need to automate, of course. So that's the donkey. In Dutch there's a saying, een ezel stoot zich in het gemeen geen 2 keer aan dezelfde steen. So learn from your mistakes. Don't do the same thing all over and over again. And that's when we started to really think about the 2 and more topics you were just talking about. We need to automate, and we need guardrails. And then we came about like the challenge we were talking about. We were at the point, manual labor, error prone, not reproducible, complex recovery. The teams were also very dependent on the CPET team. Decoupled tooling, so for every capability they wanted, I want Grafana, I want Tekton, I want SSO, for instance. It was automated by ArgoCD for us, but they needed a pull request for this, a pull request for that. So that was like a lot of work for them and for us. Individual access control, how do I get access to my namespaces? They had to organize it themselves within their own infrastructure as code, the deployment repos, for instance. Well, a lot of issues that we were facing, and we need to move, nice for the time. We needed to move to like a future where less toil, no toil, less error prone, well, the opposite. A unified API is also interesting. Just one way of asking for a capability, and not 10 different ways of asking for Grafana and the other operators stuff. So that's also a thing we were looking at, and an easy way to get namespaces, although you don't have the self-provisioning right they had in the past. Because we don't want to say, hey, this is the namespace you have to work with, and that's it. Just deal with it. We wanted to have the liberty they had already. Just create a namespace if I need one. So this is where we were, and of course this is where we want to go to. So the solution was, in our opinion, and which has helped us so far a great deal already, is that we made an operator. It's made in the operator SDK. The language is Golang. We have it CSD managed, of course, so we can deploy in each cluster depending on various versions that we want to support. And the CRD that comes with it is the kind PaaS, and that we designed when we started off. Like, how should this CRD look like? Well, what does the operator provide in terms of capabilities? What we're providing is like operators or capabilities that cluster admin rights are necessary. Like our team, the developed DevOps teams, they don't have cluster admin rights, so there's certain operators they cannot install, so we have to do it. So in these circumstances, the PaaS operator, well, you can configure any type of operator you want, for instance SSO or Tekton. You say I want Tekton, I want SSO, and the operator will provide this capability for you. And sometimes teams can install an operator or use something like ArgoCD, for instance, but you need to have the right setup in order to use it well. And sometimes this setup can be a bit complex, or for instance that we write recipes, and these recipes only will work if ArgoCD has a certain configuration. So in these cases also, we will put this capability into the PaaS operator, and it will deliver you the capability configured the right way for our recipes also, because it can be complex, and it makes it easier for the team, so they don't have to know a lot of stuff. And also, which I was just mentioning, like if there's static namespaces, like develop, test, acceptance 1, 2, production, that's what a team needs. And they're like always there, so you can put it into the operator, into the configuration of the PaaS, and it will give you these namespaces. For instance, also a sandbag of John Doe or Anita Doe, they want their own namespace to work on, they can just create one, so it's easy with the operator. And there's also dynamic namespaces, like I make a pull request, okay, I get a namespace with all the information of a deployment repo in this namespace. And in the end, what's the scope of a PaaS? Because I just was telling you, you create a YAML kind PaaS, you configure your stuff and you get all these capabilities. But actually, what is the scope? Well, actually the scope is a deployment repo. And what does it give you? It gives you the DTAP environments, so the different environments, for build, deliver, and run. So it's not only about deploying an application to production, it's also giving me the capability to start building my applications. So a Tekton namespace to start building with my pipelines, or to deliver, I need ArgoCD, for instance. So it's the whole package. It's about building, starting to build applications. It's about getting them into production, and it's also about managing the introduction, and it's also about experimenting within your namespaces. So that is the scope of a PaaS. It makes, if you got within, for every deployment repo, got your build, deliver, and run, then you have all the necessary capabilities at all stages for development. So if I got PaaS, I can start developing, I can start delivering, and I can start deploying and running. Another stuff is, it's a kickstart for development, but because you got a lot of parameters at the right place, and you can start right away with your Tekton, for instance, and it's portable, because I just change a team within my PaaS, or I say this team gets my PaaS, and they get everything for this application. They don't get the application, but they also get their Tekton environment. They also get their ArgoCD for deployment. They get everything that belongs for running, building, and delivering applications. And it's extensible. So if you want more capabilities, it's fairly easy to put them into the operator. Now we've got like 4 capabilities almost available. Because the operator doesn't do anything with the operators. Our operator doesn't do anything with the operators we're installing. We're just like pointing at repos that are used to deploy the capabilities. So this is about the scope of a PaaS. And actually now we're at the point of how it works.
Yeah, so the main goal, the main thing that we wanted to fix was that we wanted to hand our development teams the possibility to basically request a PaaS, and then they should be in full control of everything they needed in their own space. And one of the other things that we wanted to do was the ability to basically have them run on one cluster, but let's just say that this one cluster blows up in a very terrible way, right? Then basically we wanted them to be able to move their workload to another cluster, which basically means that we wanted a bootstrap process that enabled them to configure everything with just a tiny bit of code, and then from there on they could basically spin everything. And that's basically what we call the bootstrap. That's the problem that we're trying to fix. Now, how did we get there? The customer basically creates a YAML file. I'm going to show it to you a little bit later, which basically has all of the details they need for their PaaS. Our PaaS operator finds it out and basically creates all the other stuff. But the most important thing that it does is it creates a namespace for the customer's ArgoCD. We use ArgoCD ourselves internally, but that's not on this image. It's somewhere in between here, let's just put it like that. Anyways, so this ArgoCD has only got one application, and it's predefined, it's pre-created by our operator, and it basically goes upstream to find out what's the stuff that you need done. That is what we call the bootstrap application. Now this bootstrap application basically points to a GitHub, to a Bitbucket repo for the customer, for the dev team, and they can put everything on there, and basically what they have is all of their other applications. So ArgoCD spins up, it connects to their Bitbucket repo and finds all of these other applications, and then it knows, I need something for develop, I need Tekton, I need a lot of other stuff. And from there on, basically ArgoCD starts to create all of the other stuff and fill everything in. The only thing that they need to provide is the name of the PaaS, and let's just say credentials to their Bitbucket repo. So that's the whole thing. There's only one slide for me, so that's that's cool, right? But now we come to the scary part. What you can find over here is, I'm just filtering on, and by the way, sorry, I know that it should be Kubernetes, but internally we use OpenShift. We want to fix that in the future, near future. We're getting there. So anyway, I looked for namespaces which starts with the prefix set mrk, and there's none. Cool. What you all can also see is that there is one PaaS object which is called set beheer. But what I'm going to do is I'm going to create a new set, a new PaaS, and this is basically what the customer, the dev team issues through Bitbucket, through our Bitbucket, and then our Bitbucket picks this up and creates the PaaS on OpenShift. But now I'm going to do it manually. For sure. Doe maar even. Die ook even weg? Ja, precies. Ja, misschien helpt het. Weet het niet. Ik weet het niet. Zoiets? Beter, hè? Mooi. So what we have is a PaaS. It's a kind PaaS, and it's the API version cpet.belastingdienst.nl, which basically means that we invented it. We are the guys that decided what the API is about. We have a name called setMRK, and what you might see is that there's no namespace, and that's because it's a cluster-wide object. Like namespaces and groups and users, it's cluster-wide. And then we have capabilities. We have ArgoCD, and we have it enabled, which means that we will have a namespace with ArgoCD, and all of the stuff of ArgoCD is going to be installed in there. And here you can basically find things that basically tell ArgoCD with the bootstrap where to find the rest of the stuff that I need to deploy. So that's basically, this is basically filling in the bootstrap. Let's just put it like that. We can set quota, we can leave it out. There's defaults, there's sane defaults actually. I just wanted to show you that you could set it. Then we can do Grafana and SSO, but basically we have disabled it. And we can do Tekton, and for Tekton I decided not to put in any quotas, which is fine. Now, what do we also have here? We have a block called groups. And basically what happens is this is setting up all of the, how do you say it, LDAP sync stuff. So this group basically is synced into OpenShift on a daily basis. If users change or anything, basically the dev teams can manage that themselves, and the next day everything is on the cluster. So that's what's happening over here. And we're creating one extra namespace called Marktplaats. We could basically put anything in there, which is fine. We could have a list. And then we have some quotas and some SSH secrets. If I have the time, I'm going to tell you what that is about. But basically, this is about the SSH secrets to connect to Bitbucket so that ArgoCD can go to Bitbucket on a secure manner. That's the whole idea. Cool. Now I'm going to create it. That was easy enough. And what you probably will see now is that we have a lot of namespaces. What's interesting to know is that if we look at, for instance, set Marktplaats, set MRK ArgoCD, we have resource quotas set up. So the way that we do it is every capability has its own resource quotas, and then all of that list of namespaces, they all have a combined cluster resource quota. So you could have a gazillion applications on a gazillion namespaces. You have only one resource quota, block to the resource quota. That's a design decision that we made. Now, furthermore, what we have is we have an ArgoCD, set MK ArgoCD. We have a route, and if the gods are happy, let's just see. There we go. Now, it might just be. There we go. So what you can now see is that this Bootstrap application already started running, it started syncing, and the first thing that it basically noticed was that there's 3 other applications that needed to be there. So basically, ArgoCD created those applications and then started to manage all of those applications, and that's how we bootstrapped the whole situation. And yeah, basically that is all of the presentation. I just wanted to show you one more thing. As an example, we have set MK Marktplaats. I showed you this whole SSA stuff, right? What is done, and this is one of the cool things that we needed to implement to make it properly secure. If we go to workload secrets, then we have 2 secrets. One of them has our private key to go to our own Bitbucket, but I created a second one, this one, which basically I just wanted to show you has these values in there. But I provided them through the PaaS, but nobody knows, and that's why we use private public encryption stuff. And this is the way that we could basically have stuff running on CN on our first cluster, and move them over to our second cluster, and basically provide him with all the secrets to Bitbucket and everything. So that was the whole presentation. That was the whole demo. I have one more slide. So this is stuff that we want to do in the future. We have now a PaaS NS. A PaaS NS basically means that if you create a PaaS NS in a namespace which is belonging to a PaaS, it will create that namespace for you. So basically our customers could very easily create extra namespaces while we still enforce our naming conventions and all of that stuff. Take care of SSR secrets, everything is taken care of. So that's one of the things, we already have that in. We would like to have auto-merge, which basically means that if customers say, I need more resources, that under certain conditions, basically it is auto-merged and we don't have to take care of it. So we try to remove ourselves from the developer process even more. We are open sourcing this. That doesn't mean that everybody is gonna run it, but I think that a lot of, well, let's just say government agencies might just be very happy with all of this stuff. So we're open sourcing it anyways. We're building a break the glass solution, which basically means that in production you don't have all of the permissions, and then you could acquire them, and it's registered and all of that stuff. And we want to build a web UI so that you could basically click your PaaS instead of needing to type in YAML files, which I am very fond of YAML files, but nobody else is, which is fine. But that was the presentation.
Now for some questions. We already have a question. Nice.
Hey, thanks guys. That was a great presentation. I had one question for you. Have you, so when you create a namespace, you are trying to enforce a lot of configurations and generating resource quotas and other things. Have you explored Kyverno? Like, do you have any thoughts on it? Because that does a lot of generation and enforcing guidelines for you.
Yeah, it's funny because we created the PaaS NS because we wanted to replace something that was done by Kyverno. The situation was that we had customers that were doing stuff wrong with ArgoCD applications, and that means that ArgoCD was constantly updating it, and Kyverno was fully overloaded. Which was, I mean, it's not weird that it happened, but on the other end, we had a lot of customers basically that created an issue and basically overblew our own cluster. So we still use Kyverno for a lot of stuff, but all of this stuff we basically wanted to be fully in control with our own operator.
We would not like to mix capabilities. So like if you get Argo, actually you should get Argo and not something managing stock within Argo like Kyverno. We actually do use Kyverno rules, but only to manage our own stuff and like enforce some like naming conventions for the namespace so that people will go on.
Yep.
Thank you for the presentation. My question is that why did you need to create an operator? Because with the other ArgoCD, you could easily create another ArgoCD and all those configurations with just writing some YAML file as a set of templates. What is the exact need for a new operator?
So there's multiple reasons there. First of all, we wanted to provide one API. And when we didn't have that operator, basically we handed over to the customer, well, you could create your own namespace, but you need to fill in this stuff. And so there was a lot of resources that they needed to create. And now basically they have this one API. I need a capability, and a lot of resources are created by our operator, managed. So that was one thing. The other thing is that we do some stuff like the SSH encryption stuff that you could never do without a self-built operator. And as an example, we have and we could change that API, by the way, so we could do stuff. But now we have a config map which basically says which all of the groups are synced. And that is a config map with one key data. And what we now do with our operator, because it was provided to us by someone else, by the SIT team actually, we wanted to basically change the contents of the data field, which was impossible with anything else than with an operator that basically could pick this resource, take out the data, change stuff around, put in new data. So some of the stuff that is very trivial, very easy to set up, if you look at it, it gets very complicated if you don't use anything. And it was very easy to implement it in Go. So I'm a fan of Go. It was in there, it was just hidden because, as I mentioned, we used OpenShift. So I'm sorry for that. But OpenShift calls it SSO. And so basically what we do is we use the SSO operator, single sign-on operator, and we provide it as one of the capabilities. The way that we got there was we provided it to, and this is cool about the collaboration, we provided it to one of the dev teams, and we said like, we will enable it for you manually. And then he started doing all kinds of stuff, and then he handed that over to us, and then we said we will build a capability out of that. So that is cool because he created it because he needed it, and then he brought it to us, and now we are enabling the entire Dutch tax office with that capability. But we use KeyCloak internally. Yeah.
Cheers. Hey man, that was great. Great presentation. I'm with Rijkswaterstaat. And my team is effectively trying to do exactly the same thing.
Let's collaborate.
Yeah, sure. So when is this becoming open source?
Tomorrow.
That's my question, right? Gee.
There is a process for it, and we had one team that went before us to open source code, and I don't think they are open source right now, and they started about 6 or 8 months ago. Which is a terrible answer right now. On the other end, yeah. So the guy that I know that basically hands that whole process mentioned that they basically took out all of the heavy lifting. So now it should be able to be doing that within a month. That's the good answer, but now also I have some bad news. It's not high on our priority list as of yet. But let's just talk, because maybe we could just put it on top of our priority list.
Yeah, great.
Let's just do that. Yeah. Can we do it? Of course, yes.
Before Christmas. Yeah. Before next Christmas. Last question? Perfect.
Let's share details.
It's far away. Sorry. Not a runner.
Could you share some more details about how many projects run on each cluster, as well as, and how do you handle RBAC within that scope, if that's the case, as well as how teams promote their project configurations across multiple environments that they would have?
Microphone?
I have to run again.
At the moment, we have about 3 production clusters and 3 OTA clusters, or when you know OTA in Dutch. And I think about CN2, there's about, I don't know, 30 PaaS YAMLs right now. 30, well, yeah, a team can have multiple PaaS, of course, because they can be in charge of multiple applications, of course. But I think there's about 30 PaaS now at a cluster. So that's the, and also it depends a lot on the PaaS, because you can have a PaaS that say I need 500 CPU, and you can have a PaaS with a front end that only needs like 10 CPU, and then you're ready. So depends a lot. So within this PaaS you can state, depending on the application, how many resources you need. It can be CPU and also memory. So that varies. But we're like, as I told you in the presentation, 50 teams now. And some teams have multiple PaaS, so you can do some calculation. And next year, we grew a lot, so we're 20 people now. But there's a lot of people that have to be onboarded, need to be guided, enabled, and helped with really building cloud-native applications. So I don't know if it helps. Like we're at 6 clusters, and we can go up to 30, depending on the scope of how many resources PaaS need, how many you could put on the cluster. But the presentation, the bootstrap enables us just to take a PaaS from one cluster, put it on another cluster, and everything, the whole build, deliver, and will be available on that cluster.
And also, we aim high for our dev teams. So basically, we say we want you to do everything as code, which basically means that everything should be in their Bitbucket, and they should be using our bootstrap to basically. So we are forcing them in that direction to do all of the configuration management. And they could, so what we do is we use customize with overlays, and we tell that to our customers as well, so they could use that technology to basically do that on every cluster in their own way as they would like to, and things like that. So, yeah.
Also, what the DevOps teams develop is GitOps based, that in mind. So everything is in your deployment repo, and that's your source of truth.
And ArgoCD is the bomb. Basically, he's doing everything for us. Yeah.
Thank you a lot. Thank you a lot. Let's close on this one. Round of applause.